Hello and welcome to Train Signal. This is video number 3, Installing Linux. This is part of Fast Track CBT Video, Linux Networking and Administration. Let's move on to our table of contents. We've got a lot of exciting topics to cover in this video. First off, we'll review our scenario with the Big Sky Fishing Company. Then we'll learn about identifying the proper hardware when installing Linux. Talk about the different methods for installing Linux, learn some Linux multimedia options, determine a purpose for the new Linux machine that we'll be installing, how to configure the Linux file system, boot managers, network options, and how to configure Linux installation parameters. Then we'll do a real live installation of Linux, and you can see exactly how all these things work. Now let's move on to our scenario. Back at the Big Sky Fishing Company, you need to get the new Linux server up and running. The first step to doing that, of course, is to install the Linux operating system. To do this, you need to consider if the hardware will be compatible with Linux, what the server's purpose will be, what applications will be needed, the layout of the file system on the hard drive, and a number of other installation factors. In this video, we'll install the Red Hat Fedora Linux operating system, taking all these factors into consideration. So first off, let's talk about identifying the proper hardware for installation. This is one of the important Linux Plus objectives. Objective 1.1, identify all system hardware required and check compatibility with Linux distribution. This relates to CPU, memory, drive space, and the scalability of the server. So let's talk about this important objective. First off, you need to determine, is this going to be a workstation or a server or a Linux appliance? An appliance is a dedicated piece of hardware usually sold for a certain purpose. Typically when you install Linux, you might be putting it on a workstation or a server. You need to know what devices and what device drivers are compatible with Linux. You can do this by researching on the internet, checking with the manufacturer of the hardware that you're using. For example, will your mouse or will your scanner or your modem or your network interface card or even your hard drive interface, some of the things that you might take for granted in Windows, will all those things be compatible with Linux when you install Linux? You need to do research on every machine that you install Linux on. If it's new hardware that you haven't installed Linux on before, you need to make sure you do research to make sure that hardware is really going to work with Linux. You need to know if you're going to do a text versus a graphics installation. That points out the importance of whether or not the video card is compatible. A lot of the newer, higher-end video cards that you might put on a PC, especially those 3D high-end video cards, a lot of those aren't compatible with Linux because they're sort of cutting edge and they're designed for gaming on Windows. These are things you need to research. The Linux Fedora operating system supports 3 different platforms. There's the i386. This is your typical Pentium 4 processor, a standard AMD processor like an Athlon. Then there's the x86-64 operating system. This is a 64-bit compilation of Linux Fedora that works with AMD 64 processors. Then there's the PowerPC version of Fedora. This works with Motorola's PowerPC or IBM's PowerPC processors. You need to make sure you're familiar with the memory requirements of Linux. You know, does the machine that you're installing Linux on have enough RAM to support that operating system? Then you need to know the hard disk requirements. How much hard drive will the operating system require? And a lot of that, of course, is based on the applications that you intend to install inside the Linux operating system. If you install the bare minimum, you can get away with a lot less than if you choose to install everything that's on the Linux Fedora distribution. Take into account the speed of the hard drive and the interface. Is this an SATA interface, a SCSI interface? What type of interface does this have? That'll be important when you install the drivers, the hard disk drivers. Now hopefully everything you have just is magically compatible and you don't have any problems. That's the perfect world when it comes to installing Linux, and many times you'll have that, but other times you really need to do your research. What type of controller will you be having? We talked about that, an SATA or a SCSI. What type of hard drive controller will be in the machine that you're controlling or installing Linux on, and is it compatible? Think about the hard disk requirements versus partitioning. When you go to partition the Linux operating system, when you install it, you can just take the defaults. Partitioning means what files are installed on what drives. And inside that drive, you can partition the operating system into different partitions. Partitions are little blocks of hard disk space set aside for a certain purpose. Now, if you're used to installing Windows, you usually just install Windows on one partition, the C drive, and everything's installed on there. And hopefully you have enough space to hold everything and you never have to expand it. But if you have experience working on larger servers, especially database servers or email servers, you may need to have a partition for the operating system, partition for logs, a partition for the database, different partitions for different purposes. In Linux, this is very common. You have different partitions for different purposes, different pieces of the operating system. In fact, the minimum number of partitions you'll have when you install Linux is 3. You can go beyond that and have many more partitions. Now, don't get frightened away by the thought of having to, lay out the hard drive space and partition out all these different pieces of the operating system. Because when you install Linux, it can do this for you automatically. And we'll see that when we install Linux ourselves. So this is just something to take into account, partitioning and the hard drive space, type of hard drive, speed of the hard drive. Now to learn more, let's go and look at the Fedora release notes, and we'll learn exactly what Fedora requires. So if we scroll through here, these are the latest release notes for Fedora Core 5. That's the version we'll be installing. And if you scroll down, you can see here the architecture-specific notes. Here's information on PowerPC, x86 specifics, hardware requirements, 64-bit specifics, packaging, so on and so forth. What we're interested in is the x86 specifics for Fedora and the hardware requirements, because that's a platform that we'll be installing Fedora on. So I'm going to click on that link. This takes us down to specifics for Fedora on the x86 platform. If we scroll down here, it talks about the following specifications are stated in terms of Intel processors. Other processors such as AMD, Cyrix, and VIA are compatible with the equivalent. May also be used for Fedora Core. So there's a few different processors that can be used. The minimum is a Pentium class, optimized for Pentium 4 CPUs, but supports earlier models such as Pentium, Pentium Pro, Pentium 2, Pentium 3, compatible AMD and VIA processors. Recommended for text-based is a minimum of 200 megahertz in the Pentium class. Recommended for graphical is a minimum of 400 megahertz in the Pentium 2 class. Minimum RAM for text mode is 128 megabytes. Minimum RAM for graphical is 192, and recommended for graphical is 256. So the recommended for graphical, I think that's, to me, the most important, because that's how most people use Linux. The recommended amount of RAM is 256 megabytes. Now let's look at the hard disk requirements. The hard disk requirements, in practical terms, it says additional space, let's see, may be needed, minimum of 90 megabytes to as much as 175 megabytes for everything. The complete package can occupy over 9 gigs of hard disk space. So it varies, obviously, it varies greatly. And then, of course, you'll need to leave space for user data. So it doesn't give you a lot of specifics because the hard disk requirements vary greatly based on what you install, the different packages that you choose to install. So let's close this out. Let's also mention the scalability of Linux and of the hardware. Scalability is important. Scalability just means if I install Linux on this machine and the machine needs to grow, or the requirements of the machine need to grow, can that machine scale or grow to meet those requirements? So say I configure a server that's for 10 users, and the number of users grows over time, and I have 50, 75, say 100 users. Can I add additional processors, additional RAM, additional hard drive space in that server to allow it to scale and accommodate those additional users? That's something important to take into account whenever you install Linux, especially on servers. Scalability isn't as important on workstations because today typically people, they would just, workstations are typically scalable enough to allow some growth, and you don't typically have a lot of growth on a workstation because it's a single user machine. You get a lot of growth when it comes to servers, file servers, email servers, web servers. You can't predict a lot of times the growth requirements, and you need to make sure that your system will be scalable to accommodate that growth. So let's move on to the next objective. Now let's talk about the Linux Plus Objective 1.2. That objective says determine the appropriate method of installation based on the environment. So if you have a standalone PC and you can just stick in a CD-ROM, great, that's probably the easiest way to go. But other times you might need to use a different method of installation, like a boot disk, over the network. You can use DVDs, you can boot from a different operating system to install Linux. There's a variety of different ways. So like I said, normally you're booting a CD-ROM to install Linux, and it isn't done typically from Windows or another OS. But some distributions do have a program that begins the Linux installation from another OS like Windows. Still, the most popular version or most popular method of installation is from CD-ROM. The boxed versions of Linux, some of those come with floppy disk, boot disks for installation, and then you move to CD-ROM. But typically you're booting from CD-ROM. Now, when you download off the internet, there are some options to create a Linux boot floppy from DOS. Some issues that come up are that older BIOS versions don't support CD-ROM boot, but I haven't run across one yet that doesn't. That's me personally. I'm sure there are a lot of BIOS versions out there that don't, though. DVD ROMs are also an option. Novell SUSE Linux does this, and that's a pretty cool option. You can actually download the whole DVD in some cases and create a full DVD that has all the Linux installation on that one DVD. That's a pretty cool installation method. Another option is a network installation or a hard disk partition installation. So you can install Linux over the network using different protocols. That's an option. I've even seen where you can boot with like a CD and install it over like the internet. Let's scroll down here. Running Linux from a CD without ever installing it is also an option. If you go and look at Slackware.com, they have a downloadable boot or distribution of Linux that you boot, but you never actually install it. So that's a really cool way to demo Linux, or just to try out Linux, see how it works, or if you want to do some things in Linux but never have to install it. I know I've used some network auditing tools that do this. They've got a boot disk of Linux. They've got all the tools built in, already compiled. You don't have to install them or anything. You just boot up in Linux. You use all these different Linux tools that aren't available usually in Windows, and then you just take out the CD, reboot, and you're back in Windows. So it's a pretty cool way of using Linux without having to install it. We're going to be downloading Linux here in just a second so you can see what that looks like. Before we do that, I want to point out the method of interaction during installation. 3 different ways of interacting with the installation. The first would be the GUI, the graphical user interface. That's how most users do it. The next would be text, full text installation. You never see any graphics. You don't typically use your mouse. And then the third would be scripted. So you can script installations of Linux. You can create CDs that you just stick it in and it installs the whole thing. Now that's typically for a more experienced user who's done a lot of Linux installations, knows exactly how he wants that installation to be done, creates a script to do it, and it just installs Linux, and when it's done it reboots and Linux is ready to be installed without ever answering any questions. But like I said, GUI is typically the most popular method, and that's how we're going to be doing it. So now let's look at how do you go and download Linux. I'm going to open my web browser here. You know, if you start off at Google, easy way is you type in Fedora for Fedora Linux. The website is actually fedora.redhat.com. If you click there, it takes you to the Fedora website. Here's where you can download Fedora Core 5 Now, and that's what I've done, and that's what we'll be installing in just a second. But also here's the documentation, news, new software, all sorts of good information. So if you click on download, here you need to choose your platform. We talked about the different platforms. We're going to use i386, so I'm going to click on that. And this takes us to an FTP site, actually in another country, where these distributions are hosted. So here you have Fedora Core 5, that's what the FC5 is. Here's the platform, i386, that's the Pentium 4 processor we'll be installing this on. The disk number 1, 2, 3, 4, and 5. And then this is a .iso file. This is a CD-ROM image, is essentially what this is, that will be burning to CD-ROM. Or actually, what you can do is you can mount it and use it that way as a virtual CD-ROM. Another thing here is the DVD version. So here's the full DVD. Notice it's 3 gigabytes. So you have to have a pretty good, download or pretty good bandwidth connection here to download this 3 gig file. But if you do, that can be really cool. If you have a DVD burner, you can burn that, and then you can, install it using a DVD-ROM. Here's the rescue disk, and so all you're going to do is just click on these and start downloading them to your hard drive, then burn them as a CD. And a lot of programs, I'll show you one here, like this one I'm using. Once you have the files, Record Now, DVD, CD recording software. This is one that just happened to come with my CD-ROM drive. I'm going to click on that just to show you how this works. And here it has an option that says Burn Image. Create a disk from an image already on your hard drive. So if I click on that, it asks me for the name of the image. So if I click Browse, here's my Fedora Core disks 1, 2, 3, and 4. So if I choose disk 1 and I choose my CD-ROM drive, I put in a CD-ROM and click Burn, it'll make that disk for me and it'll be bootable and everything. All I have to do is take it out, put it in a PC, boot it up, and there you go. I'm installing Linux. So let's close this out. So you see how to download Linux and how to create the CD-ROMs that you would use to install it. Now we can move on to our next objective. The next objective is Linux Plus Objective 1.3. Install multimedia options, and it just mentions video, sound, and codecs. So it's a very generic objective here. Let's scroll down and let's learn a little bit about this. First off, when you run Linux in text mode only without graphics, Linux works with just about any video card available. So that's something to note. However, when you run in graphics mode, you need to be very careful what video card you're using to run Linux. Specifically, you should check the compatibility of the Xfree86 and the x.org-x11 server with your video card. You can use this by going to these websites, xfree86.org and x.org. These two websites will tell you if the video card that's installed in your machine is going to be compatible with Linux when you run Linux in GUI mode. In general, it's best not to try to use a cutting-edge card, as support for video cards in Linux is usually behind the card release. During Linux installation, you will have the opportunity to set your video resolution and color depth. About sound cards, Linux supports most sound cards. The standard Linux kernel includes two sets of sound card drivers, the Open Sound System or OSS drivers, and the new Advanced Linux Sound Architecture or ALSA drivers. During Linux installation, you'll have the opportunity to test your sound card and see if it's compatible. Of course, if you're not interested in using sound, it really doesn't matter if your sound card's compatible or not. But at some point, you may want to listen to music. You might want to record something using a microphone, or just listen to a video, let's say, off of the internet. So you might want to test your sound card or make sure your sound card is compatible. Now, codecs are computer programs that compress or decompress audio and video streams. You may have to download codecs from the internet to support certain audio or video types. Now, why codecs are important is, say you go to a certain website and they've created some audio file, and it's encoded in a certain codec. Well, that codec may or may not be available for Linux. So it's something you need to take into account. Besides knowing whether or not your sound card's compatible, you also need to be able to find the codecs that you need to listen to certain types of video and audio streams that you might download from the internet or obtain from CDs or have from a variety of different programs. Now let's talk about Linux Objective 1.4 and 1.5. This Linux Plus objective says, identify the purpose of the Linux machine based on predetermined customer requirements. For example, is it an appliance? Is it a desktop system, a database, a mail server, or a web server? And then 1.5 says, determine what software and services should be installed. Are you going to install client applications for a workstation or server services for a desired server tasks, say like a web server? So these two objectives, kind of go hand in hand. So let's talk about these. The most important question to me is, what will this machine be used for? Is it going to be a desktop system, a database server, mail server, web server? What are you going to use this machine for? And based on the answer to that question, that pretty much dictates what software will be installed, the hardware requirements, how much hard drive space you need. A lot of the different things that you need to know to install Linux will be answered by that question. Now in Windows, this is usually pretty cut and dry, but not so in Linux. And I say it's cut and dry in Windows because a lot of times it's dictated by the operating system. So if you're installing Windows XP Home or Windows XP Pro, well, that's going to be a workstation. On the other hand, if you're installing Windows Server 2003, well, right off, that's going to be a server. In Linux, the Linux operating system can be installed on either a low-end PC or a very high-end server. So it's the same operating system no matter where you install it. So the operating system itself really doesn't dictate what the machine will be used for. And this is because most all server applications are included in the standard Linux distribution. So Apache Web Server comes in the standard Linux distribution. So you could install Apache Web Server on your PC or your laptop that you're installing Linux on, even if you don't plan on it being a server. When we install Linux, you'll see a variety of applications available and how you can easily install all or just the selected application pieces. So you'll see this when we install Linux, and we'll talk about it. But I wanted to point out the importance of this Objective 1.4 and 1.5 and how usually this is answered by what will this machine be used for, and how that's something that you should really ask yourself before you select the hardware and before you begin installing Linux. The next Linux objective is Objective 1.6. It says partition according to pre-installation plan using fdisk. And then it talks about these different partitions here, /boot, user, var, and home. It talks about swap, RAID, hot spares, and LVM. So this is what we're going to cover in this slide. Now, unlike Windows, where the entire OS is installed in one partition, usually just one directory, even like C:\Windows, the Linux OS is typically more spread out. In Windows, a partition corresponds with a drive letter, like C or D. Partitions are logical disks carved out from physical disks. That's an important thing to know there. Partitions are logical disks carved out from physical disk. These pieces of disk are used for a certain purpose. Linux typically uses the PC partition system made up of three partition types. Those are primary partition, extended partition, and logical partition. Now, an extended partition serves as a placeholder for a logical partition. So a logical partition resides in an extended partition. To Linux, these partitions don't mean a lot. Primary and extended partitions are numbered 1 through 4, such as /dev/hd1, that would be the name of a primary or extended partition, and logical partitions start at 5 and go up. So /dev/hd5, if you saw that, you know, oh, that's a logical partition, because logical partitions start at 5 and go on up. Now the master boot record, or the MBR, is where the partition table is stored. Bootloaders, which we're going to discuss later, are also stored in the master boot record. Now note the difference between the / directory and the /root directory. In Linux, the root, or the top of the directory tree, is called /. Okay, this / right here, /. But that's also called root because it's at the top of the directory tree. And the directory tree you could think of as an inverted tree, meaning the bottom of it, which would be like the root on a tree, is /. And then it just gets bigger and bigger from there, and it blooms out like a tree. So like at the top of a tree where all the leaves and branches are, that's all the directories and folders in your Linux file system. So the root is the bottom of the tree where the roots connect to the ground. So that's why they call it root. But there's also another directory called /root. So just to prevent any confusion, I'm going to call this directory /root whenever we talk about it. And I'm going to call this directory root or /. The /root directory is the home directory for the root user. So that's the super user. That's where his home directory is. When you install Linux, you'll be asked if you want to automatically partition your disk or manually partition the disk. Usually automatic will work fine, but not always. I recommend just to everyone to automatically partition your disk. If you have problems, you can go in and manually partition it. That is unless you're an advanced or more experienced user and you really want to go in and manually partition the disk drive. But if automatic works, I say go for it. Now let's talk about LVM. LVM is the Logical Volume Manager. Now it isn't a program, but it's a design to allow flexibility of disk management. To understand LVM, you must understand the following three terms in these three bullets right here. They are physical volume, volume group, and logical volumes. First off, a physical volume, also called a PV. A physical volume is another name for a regular physical disk partition that is used or will be used by an LVM. So a physical volume is a regular physical disk partition. Now a volume group is any number of physical volumes on different disk drives that can be lumped together into a volume group, also called a VG. Then we have logical volumes. Now volume groups must then be subdivided into logical volumes. So a volume group is broken up into logical volumes. Each logical volume can be individually formatted as if it were a regular Linux partition. A logical volume is therefore like a virtual partition on your virtual disk drive. So these logical volumes to the operating system look like physical volumes. But really what the Logical Volume Manager allows you to do is to take your real physical disk partitions, put them in groups, and then break them up into these logical volumes. So this is a design that allows you flexibility. Because of the LVM, you can do cool things like just move a logical volume from one disk to another, and the operating system never has to know the difference. So the LVM provides you a lot of flexibility in how you manage your disk information. Because of the LVM, you can expand disk, you can shrink disk, you can do all sorts of amazing things. But you don't need to know about all that right now. Just know that the LVM is a disk management design that provides great flexibility of disk management. Okay, let's scroll down here. Now let's talk about the Linux FDisk program. FDisk is a tool that can be used to partition your disk. However, when installing in the GUI mode, you won't be using FDisk. The Linux FDisk program is named after the DOS FDisk program, but the Linux FDisk program has more functionality. Commonly, certain directories are split into their own file systems. Here's a list of those directories. The /boot directory. /boot holds critical boot files and is typically 5 to 50 megabytes in size. The /user directory holds most Linux programs and is typically 500 megabytes to 6 gigs in size. /var. /var holds variable files in size such as log files and mail queues. /home holds users' directories or home directories, but not the root user's home directory. Could be 200 megabytes to 200 gigabytes in size. Then there's swap. Swap is a file system, but it's not a mounted partition. Swap is used to help out the operating system when not enough RAM is available. So if, say you have 128 megabytes of RAM and you're starting to run out of RAM, the operating system might take 50 megabytes of data that's in RAM, move it off to swap, and free up 50 megabytes of RAM. The swap partition is usually 1.5 to 2 times the system's RAM size. So if you have a gig of RAM on your server, you might make 2 gigs of swap on your swap partition, 1.5 to 2 gigs of swap. Then there's the /user/local file system. This holds programs that are unique to this system, especially compiled programs, usually 100 megabytes to 3 gigs in size. There's the /opt file system. This holds third-party programs and files, usually commercial programs. I always think of this as being optional. It's the third-party programs you installed that usually go there. There's the /temp file system. It holds temporary files, usually 100 megs to 200 gigs in size, so it can vary. Finally, there's the /mount or /mnt and the /media file systems. These aren't partitions, but they're used as mount points for removable media. So in Linux, a mount point is a folder where you mount a file system on top of it. And we'll learn more about mount points in future videos. So these aren't really file systems, really they're just folders that when you put in a CD, that CD goes on top of that folder. So that CD might show up in the /mnt directory. Finally, let's talk about RAID volumes. RAID stands for a redundant array of inexpensive disks. RAID is when the operating system or a hardware controller is creating multiple pieces of the same data for redundancy or performance. There are different levels of RAID. You might have heard of them: RAID 1, RAID 0, 2, 3, 4, 5, 6, 10. There's a lot of different RAID levels. RAID 5 is probably the most popular level of RAID. RAID can be configured at installation time, but it's not for a new Linux user to do. We'll cover RAID in more detail in future videos. Just so you know what it is right now, RAID is a redundant array of inexpensive disks, and it's when either the operating system or a hardware controller takes one set of data, breaks it up into multiple pieces, and even redundant pieces, so that if a disk drive goes out, that data can be immediately recovered without the operating system ever knowing the difference. So RAID is really cool when it comes to redundancy. You know, you can have 5 drives, let's say, in a RAID 5 array. Say one drive goes out, the whole server just keeps on running. Nothing ever goes down. RAID can also be used for performance. So you can get double the read times, say from a RAID 1 array, because you have mirrored data. And you can get twice the read performance out of those two drives that are acting as a mirrored system. Now let's talk about a hot spare. Right there. A hot spare is a disk that's used with RAID. It's configured such that if a disk drive goes out, the data that was stored on that disk is copied onto the redundant disk, the hot spare. The hot spare resumes the job of the disk that failed. So I talked about the RAID 5 array, where one disk goes out, the system just keeps on running. Well, if you had a hot spare created, that hot spare would be built with the data that was on the drive that goes out. Then you would have 5 disks. After the rebuild time completed, you would have 5 disks that were running, and the file system would be completely rebuilt and back to its original performance level. And again, the operating system and the users should never know the difference that that drive went out. You get the replacement drive from the hardware provider, put it in that array, it rebuilds that RAID 5 array back again, and no one ever knows the difference that the hard drive went out. So let's move on to our next slide. Now let's talk about Linux Plus Objective 1.7. This says configure file systems, and it talks about 3 different Linux file systems. We're going to talk about this objective and these 3 file systems right now. So when you create a partition, you format that partition and put a file system on it. So a partition is a disk area that you have formatted, and you're going to put that file system on it. Now when you format it, you have to select the type of format you want. And these 3 different choices that it listed up here in the Linux Plus Objective are the 3 different choices you have to format the file system. So they are ext2, ext3, and riser. So ext2 is the original Linux file system type. It works fine, but if the computer is not properly shut down, it can take a long time to be checked when the computer reboots. So it's subject to some corruption. The next one, ext3, solves this improper shutdown problem because it provides journaling. Journaling is a feature that keeps a record of changes to a file system so that checking it is very fast after an improper shutdown. So it's kind of like on a database, they have rollback logs and change logs. So those logs are there so that if there's any sort of discrepancy as to what has been updated and what hasn't in the database, those change logs are applied to update the database properly with the most recent changes. So that's what the journaling does. So ext3 is the most popular type of Linux file system. So ext3 is the default in Fedora, and that's most likely what you're going to have all your file systems formatted with. Now let's talk about the third one. The third one is Riser. Riser is a Linux file system that provides journaling as well as ext3, but it isn't as popular as ext3. So it's an alternative to ext3. Now please note that there are other types of file system formats for Linux. These aren't the only 3 that you can choose from, but these are the 3 most well known. Also note that the swap file system is not mounted and is not one of these file system types. So the swap file system, we talked about that earlier, it's used to page things that are in RAM off onto the disk drive when there's not enough RAM. That swap file system isn't mounted and it isn't formatted with any of these 3 file types. It's like raw disk. The operating system just uses that partition to swap things from RAM onto disk. So let's go on to our next topic. The next topic is bootloaders. Now a bootloader is talked about in Linux Plus Objective 1.8. It says configure a bootloader, and it talks about 3 different bootloaders, Lilo, eLilo, and Grub, and then multiple boot options. So a bootloader is what loads Linux into memory when the system starts. All you have to do is run a single copy of Linux on a server, and you will still use a bootloader, but probably never have to configure one or even think about it. So the default bootloader in Fedora is called Grub, and we're going to talk about Grub in just a second. But even though you don't think about using a bootloader, even when you just install a single copy of the operating system and you only have one operating system with Linux, you're still using a bootloader. You just don't ever think about it. Most people encounter bootloaders when they try to boot multiple copies of the same operating system. So say I wanted to install 2 copies of Linux on the same machine, and when the system boots up, I choose which operating system I want to boot. Or say I want to install Windows 2003 Server, and Linux all on the same machine, and I want to be able to choose which operating system when the system starts up. That's what I would use a bootloader for typically. Another thing you can use a bootloader for is to run or to choose which version of the kernel you want to run. So like say you get an upgrade, you can choose to install that upgrade with a different name essentially, and when the operating system or the PC starts up, inside Grub, the bootloader, you can say I want to boot the new kernel or I want to boot the old kernel. So it's a really handy and really useful tool to have a bootloader. So let's talk about these 3 different bootloaders. The first one is Lilo. Lilo and Grub are the most common bootloaders. Lilo stands for Linux Loader. Another type of bootloader here is eLilo. This is the EFI Lilo bootloader. It's used to boot 64-bit Linux machines, so keep that in mind. eLilo is used to boot 64-bit Linux machines. Then there's Grub. Grub stands for the Grand Unified Bootloader. It's a fancy name, but Grub was the first bootloader to boot above the 1024 cylinder. This is a problem in certain versions of the BIOS. Now Lilo can do this, but Grub has gained a lot of popularity. And like I said, Grub is the default bootloader in Fedora. So the biggest benefit again to bootloaders is being able to run multiple operating systems such as Linux and Windows or Fedora Linux and SUSE Linux, whatever combination you want to run, these bootloaders can handle that so that when you boot up you can choose which operating system you want to run. Also, you can run multiple kernels on the same machine. That's really handy when you do upgrades. So we learned about bootloaders. Let's go on to our next topic. The next topic is based on Linux Plus Objective 1.10. Now this says select appropriate network configuration and protocols, and it talks about iNetD, XiNetD, modems, and Ethernet. Sort of generic, but let's learn about these things. First off, there's iNetD. iNetD and XiNetD is how this is pronounced, are super servers. These applications on a Linux server run other applications. So if you think of Windows, you can go into the services management application. But the services management application really isn't like a super server. It's just a point of control for running multiple applications. Now, iNetD and XiNetD allow you to run, choose what multiple applications you want to run as services, but the programs that they run are actually spawned under these applications. So what that means is you have the iNetD program, and under that you might have HTTPD, the HTTP server, you might have FTPD, the FTP server, you might have TelnetD, the TelnetD server. So all these applications you're choosing to run under these programs are actually the child PIDs or child programs of these programs. So if you were to kill iNetD, all the programs that are underneath it would die also. So that's the difference. Whereas on like Windows, you can choose to run these multiple applications, but they're all independent. So on Windows, if you choose to run the Exchange program and IIS and some other service, if you kill one of those, the other ones stay running. So that's the difference between these super servers and like the Windows services application. Now during installation, the only thing network related during the Fedora configuration is what IP address configuration you want on your network interface card. You'll see this during the installation we're about to perform. All configuration of Ethernet adapters and modems will be done after the system is running. So Ethernet, just to refresh your memory, Ethernet is a LAN protocol, and it's usually used to get to a WAN like the internet, or it's used to talk to other machines on your LAN. So Ethernet is a local area network protocol. Works at the OSI layer 2, and it's the most popular protocol on a local area network. Now modems are slow dial-up but excellent for text. So if you use a modem, it's great for using command line applications across a modem, or there's even text-based web browsers you could use across a modem on the internet. But modems aren't used a lot anymore. Instead, we have DSL, we have cable modems, we have other forms of high-speed internet. Modems still might be used for medium and large-sized companies to communicate or transfer data. So at night, some companies, say you have a retail store, that retail store might dial into headquarters and transfer data. So just an example of how a modem might be used. So with that, let's move on to our next topic, and that is select installation parameters. Now this is Linux Plus Objective 1.11. It says select appropriate parameters for Linux installation, and examples they give are language, time zones, keyboard, and mouse. During the installation of Linux, you'll have the opportunity to configure these options. So when we go through the installation, you'll see it'll ask you, what language do you want this installation to use, and what keyboard do you want this installation to use? It could be a Chinese keyboard, a French keyboard, Spanish keyboard, or English keyboard, and you'll see that. And then it'll talk about time zones. It'll ask you what time zone is this machine going to be in. Do you want to use the NTP servers on the internet or local NTP servers on your network? These are network time protocol servers. They broadcast the time so that your machine can always stay up to date on the time and the date. It'll always be updated and accurate. It'll ask you, what kind of mouse you have, things like that. So you'll see this more when we install Linux. With that, it's time to begin our demonstration of installing Linux. Now, I'm going to be installing Linux not on a regular PC, but on a virtual machine using a program called VMware. This is called virtualization. Virtualization is where you have a program running on your computer, and inside that program you load an operating system, and you're able to do everything in that operating system that you can do on a regular computer. Now the reason I'm doing this is so I can record the installation of the application or of the operating system, and you can actually see the whole installation. Virtualization is an excellent tool, not just for what we're doing here, but also for testing. Say on your computer at your office, you could have a Windows server and a Linux server. You could run them both on your PC, as well as your regular Windows XP operating system that you might be using for your day-to-day tasks. So inside those virtual servers, you could do whatever you wanted to do. You could reconfigure them, you could wipe them out, reload the operating system multiple times, and never affect your regular Windows XP desktop. Virtualization is great for testing of applications because you can install something and you can just roll it back to where it was and reinstall it again. Virtualization is a very powerful new tool that's come out in recent years. And for instance, at my company I work for, we have multiple servers that run multiple virtual servers inside them. So I might have one server with 5 different virtual servers inside, one running, say, antivirus, or one running intrusion prevention, one running Microsoft SMS, one running Linux, file sharing, a variety of servers all on one physical server. Now, me installing this on a virtual server is going to be exactly like how you would install it on a PC. So when I put in the CD-ROM, disk number 1 of Fedora Core 5, into my virtual server and start booting it up, it's identical to you putting that same CD-ROM inside your PC on the CD-ROM drive, turning it on, and booting it up. So you're going to see the exact same thing. There's no difference. Everything I do on the virtual server, once I put in the CD and boot it up, that's the exact same thing you can do on your PC, just running a regular PC. You don't need this VMware software to run Linux. Linux runs just fine without VMware. VMware is just a tool to allow it to run inside my regular Windows desktop. So with that, I'm going to minimize this and we can start the installation. And you can see here on my desktop the Fedora Core 5 images that I've already downloaded. These represent a CD. Each one of them represents a CD. Now what I could do is I could burn these to a CD-ROM and I could use those as the installation media either on a server or a PC or a laptop, or I could use them as the installation media for my virtual machine that's going to run inside my Windows desktop here. Now another way of doing this is you can mount these images as virtual CD-ROM drives. So to the operating system I can mount this image on a CD-ROM drive, call it letter G or S, whatever you want to call it, whatever letter you choose, you can mount it on a CD-ROM drive that's not really a physical CD-ROM disk. And to the operating system and any other applications using CD-ROM disks, it looks like this is a real CD-ROM in a drive, when in reality it's just a file located on my desktop that's being emulated as a CD-ROM. So what I'm going to use to do this is this tool here called Daemon Tools. This is a free tool. You can download it on the internet. And actually Windows does support this natively, but it's not real easy to use. It's kind of a pain. This little tool here makes it real easy to do. So I'm going to load this tool, going to double click on that, and notice it launches this little lightning bolt thing down here, this Virtual Daemon Manager down in my taskbar. And what I do is I'm going to right click on this and go up to Virtual CD DVD ROM. I'm going to go here and I'm going to mount an image. Notice it says drive E. This is going to be drive E. I'm going to mount an image. I'm going to go to my desktop where I have these images here, and I'm going to mount disk 1 and say open. Notice it mounts it up into the operating system. All of a sudden it's like a new CD has been inserted. So it says, what do you want me to do with this new CD? I'm just going to say cancel. I don't want to do anything. And if I go to my computer, I can see if I scroll down here to drive E, there it is right there. It thinks that it's a real CD-ROM on my computer. See the little CD-ROM icon there? So it thinks I've put in this CD-ROM. Now what I'm going to do is I'm going to launch this VMware Workstation. So right now I have the Fedora Core Disk 1, that's the bootable CD, in my virtual CD-ROM drive called drive E. I'm going to go up here, I'm going to make a new virtual machine that we're going to use to do this installation test. I'm going to say next. We'll call this a typical installation of Linux. It's Red Hat Linux called Fedora. Next it asks for a name here. I'm going to call this Big Sky Fishing Supply. We'll just leave it Big Sky. Let's call it Big Sky 1. How about that? We'll say next. I'm going to use the bridge network, so it's just going to connect through my local network adapter. I'll say next. It asks for the size of the virtual disk. You can allocate the disk space now, or you can say the maximum size is 8 gigs. And VMware will just slowly use more and more disk space up to 8 gigabytes as the operating system needs more disk space. So you don't have to allocate that whole 8 gigs for the virtual hard drive for this machine now. So we'll just take that default and say finish. So what it did is it created this Big Sky tab up here, this new machine. It has 256 megabytes of RAM, it has a hard drive, it has a CD-ROM. I'm going to change the CD-ROM to point only to drive E. That's the virtual CD that we connected, and I'll say OK. It has an Ethernet, a USB controller, audio, and one virtual processor. So I'm going to go ahead and maximize this window so we can see it better, and I'll say start this virtual machine. And I want you to be able to see the whole screen, so I'm going to say full screen on this. And what just happened is the virtual operating system accessed the CD-ROM drive. It found that drive E, it found the Fedora boot disk, and here's our boot menu. So this is the Fedora Core 5 logo here. It says to install or upgrade in graphical mode, press the Enter key. To install or upgrade in text mode, type Linux text, or you can use the function keys below. So let's look at some of these function keys. Let's explore this. I'm going to hit F2 for options, and let's see what our different options are. So there's some different boot options we can choose to use here. We can disable hardware probing with Linux no probe. We can use the Linux media check. We can enable rescue mode. If we have a certain disk driver, we can do Linux DD. Linux ask method is another option, Linux updates, or memtest. Those are just some of the different Linux boot options. So let's go into F3 general. So here it says, if you're having problems with the graphical installation, you can specify the resolution you want to force Linux to use. So if you want to force it to use Linux resolution 1024/768 when you boot, you can do that. And I've had to do this on laptops where Linux is having trouble with the video card sometimes to be able to see the Linux installation or the Linux operating system when it boots up. Let's hit F4 and look at the kernel options. Here you can tell the kernel exactly what you want it to do when it boots by using a parameter after the Linux command to boot the system. It says, for example, to install on a system with 256 megabytes of RAM using no probe, type the following: mem equals 256 m and no probe after that. There's F5 here. There's the rescue option. You can type Linux rescue to boot into rescue mode for a system that did not boot properly. So these are all the different options here on the boot up. I'm going to hit F1 to go back to main, and we're back at this screen. Now we're just going to use the graphical installation mode. So I'm just going to press enter right here to enter the graphical installation mode. And immediately what starts happening is it starts booting up Linux. It goes through, it checks all the devices, the hard drive, the RAM, mounting, file systems. Keep in mind here we don't have Linux installed yet, but this is the installation program that's doing all this. So now it says a CD has been found. To test the CD media, press OK. I really don't want to take the time to test the CD media today, so I'm going to hit the right arrow. Notice my mouse isn't working here. I have no mouse control. This is the text part of the installation when it first starts up. If you notice down on the bottom it says Tab or Alt-Tab to choose between elements, space selects, and F12 is the next screen. It doesn't tell you can also use the arrow keys to go back and forth here, and you can also use the Enter key to select things as well as space. So I'm just going to use the right arrow to go over to skip, and then I'm going to hit enter to choose skip. Now it tells me that no hard drives have been found. Now I've tried this on a regular Dell server with the same installation media, and it does find the hard drive. So because this is a virtual machine, it's having trouble finding the hard drive on this machine. Hopefully you don't have that problem on the machine you install it on, but keep in mind that if you have this problem, there's a way around it, and you're about to see what it is. This is just because it doesn't recognize the hardware. It doesn't recognize the driver for the hardware. And I've installed Fedora Core 4, version 4 under VMware, and I did not have this problem. So it's a function of the difference between version 4 versus version 5. So it says no hard drives have been found. You probably need to manually choose device drivers for the installation to succeed. That's true. You're never going to be able to install Linux without a hard drive. It says, would you like to select drivers now? I'll just hit enter to say yes. Now it tells me that it's already found the AMD PCNet32 network adapter. Well, that's great. But we also need a hard drive. So to add a device, I'm going to use the right arrow and go over to Add Device and hit enter. Now this is all the list of devices that I can choose to load at this point. Now based on some research I did, I found that VMware uses a certain hard drive driver. I'm going to scroll down here, and it's actually the BusLogic Multi-Master SCSI adapter. This is the type of hard drive adapter that VMware uses. So this is the driver I need to load to get Fedora Core 5 working on my VMware system. But you can see here there's a lot of other wireless Ethernet adapters, and you're having to load these drivers because the Linux Fedora Core 5 operating system did not recognize your devices when it did a automatic probe. You know, just like on Windows, when it goes out and searches for devices, that's what Linux did. Well, it didn't find the devices you have, so you have to manually tell it what devices you have. So I selected the Bus Logic Multi-Master SCSI adapter. I'm going to hit Enter or OK. It loads this adapter for me. Tells me it's been found on my system. I'm going to arrow down arrow. Whoops. Up and down arrow, by the way, right here, go up and down between these choices. Right arrow goes between the different choices here, left and right. So I'm going to hit OK on Done, or Enter on Done. Now it says it's running Anaconda, the Fedora Core System Installer. Please wait. So Anaconda is the graphical installation program that you use to install the Fedora operating system. So in just a second here we'll see the Anaconda graphical installation screen. Here we go. So at this point my mouse starts working. So you can see I can move my mouse, and the only option is Next or Release Notes. Let's take just a second and let's look at the release notes. I want to point out how important the release notes are to read. These are the Fedora Core 5 release notes, the same ones that you'll find on the Fedora website. But if you scroll down, there's all sorts of important information that as an administrator you really need to know. There's hardware requirements, which we looked at before. There's different package notes, kernel device information, network manager. These are new applications that are available or changes in applications. The Fedora desktop, the server tools, SMB browsing. These are all important things that as an administrator you need to be aware of. The HTTP, the web server, Fortran, security. There are a number of new changes in Fedora Core 5. The biggest thing to me that I've noticed is just the look and feel is different. But as you can see, you can scroll down here, that was just the table of contents, 29 different points. So very important. I highly recommend that you go and you read the Fedora release notes. You'll learn a lot of valuable information about Fedora Core 5. So let's close that out and we'll say Next. Now an important part of the installation, of course we talked about earlier, is selecting what language. In my case I'm going to select English, which is the default. That's the language we'd like to use during the installation process. I'll say Next. Now it says select the appropriate keyboard for the system. In my case that's a US English keyboard. So I'll take the default and I'll say Next. Okay, now this warning message that comes up is the standard message. It's not really a bad thing. It's a normal thing on a system that doesn't have anything on the hard drive. So the hard drive's completely empty, blank, no partitions. It looked out there, it saw that, and it came back and it says, the partition table on device SDA, SCSI device A, was unreadable. To create new partitions, it must be initialized, causing the loss of all data on the drive. This operation will override any previous installation choices about which drives to ignore. Would you like to initialize this drive, erasing all data? So this is saying, are you absolutely sure you want to delete everything on this hard drive? And I know this is a brand new hard drive on a brand new system, a virtual machine, and I'll say yes. Obviously, if you had Windows installed on here and you wanted to do something with dual booting, you don't want to say yes, you know. But if you had a dedicated server that's just going to be running Linux, you don't have any other partitions that you care about, go ahead, say yes. So we'll say yes here. Now it tells us installation requires partitioning of the hard drive. Hey, we talked about that. We talked about partitioning of the hard drive. That's an important thing. The partitioning layout is chosen. By default, a partitioning layout is chosen which is reasonable for most users. So there's a default here. There's a default. You don't have to do anything if you don't want to. You can either choose to take the default or create your own. So I normally just take the default because it's the easiest thing to do. However, if you want to modify and choose a custom layout, you can. There's options here to create a custom layout, or do a variety of other different things. Let's go into custom layout. Let's just look at that for a second, and I'll say next. And then what we'll do is we'll come back and we'll end up choosing the automatic layout. But I just want you to be able to see the custom layout. So let's say next. Now this is what they call Disk Druid. It's a program that's used to partition your drive in a graphical way. So here it tells you you have a hard drive that's 8192 megabytes or 8 gigabytes. By default, here's your hard drive down here. Here's your disk, and here's this free space. So what you can do manually is you can create new partitions. Click New. You can select a mount point. Here's the different mount points that are available there. You can select a file system. We talked about file systems. We talked about ext2, ext3. We talked about Riser, which isn't listed here. Or you can use the LVM. Here you select the size. If you want to use LVM, there's a certain button over here to use LVM. It gives us an error message there, but I'm not going to go into creating, partitions manually, but I just want you to see this is the interface, this Disk Druid that you use to manually create a custom partition layout on your hard drive. Another thing you can do here is click RAID. This is software RAID. Since you're not using a hardware RAID controller, this is software RAID. So the operating system is using its own resources to create higher performance or redundancy on your disk drives. So I'm just going to say cancel to this. I'm going to say back. Let's go back and let's just take the automatic, remove all partitions on selected drives, and create a default layout. So that's the default. And we'll say next. Okay, now it tells us you have chosen to remove all partitions, all data on the following drive. Are you really sure? I'm sure, so we'll say next. Or yes, I'm sorry. It gives me a chance here to review the automatic layout that it did. So let's take a look at that. If I scroll down here, it created a swap file system of 512 megabytes. That's exactly double the size of our RAM. This is a 256 megabytes of RAM system, so it created a 512 megabyte swap partition. And the format, the type of that is swap. Notice here this is an ext3 file system. This is the root file system, and it's 7.5 gigs. So it took everything else and it created the root file system. If we scroll down here, we can see on dev SDA, it took 100 megabytes, just a little bit that was left there, and created a /boot partition. Then this is the volume group. So this is using Logical Volume Manager. So let me go over this again. Here's the hard drive that we started off with here. Here's our physical disk. It created two partitions, a /boot partition and another partition on dev SDA2 that's 8 gigs. So everything left it took and it made a PV, or a physical volume, on this volume group. And then up here it took that volume group, that vol group 0, and it broke it up into two logical partitions. So these are logical partitions here, swap and root, or the /file system. So that was the default. That was how Fedora chose to break that up automatically. So pretty interesting, but you can still go in and create whatever sort of layout you want to. So let's say next. Okay, now we talked about bootloaders. Bootloaders are what allow you to select different kernels of the operating system, or different operating systems, like one type of Linux and another type of Linux, or Linux and a certain type of Windows. So bootloaders give you this flexibility. By default, Fedora installs the Grub bootloader on dev SDA. You can take that default, or you can say no bootloader will be installed. I'm just going to take the default. Grub works fine, and we're only going to be using one Linux installation here, so really we're not even going to use the features of Grub at this point. But we might need it, we might want it at some point to boot different kernels. Say we do an upgrade and we want to try a new kernel, make sure it works before we get rid of the old kernel. we might be able to do that with Grub. So I'm going to say next here. Now Fedora is asking about network devices. By default, it takes Ethernet 0, which is the default Ethernet adapter, and it assigns an IP address using DHCP, Dynamic Host Configuration Protocol. So it goes out, it broadcasts, it says, hey, I need an IP address, give me an IP address. So that's what it's going to do by default. If you want to assign a static IP address to your machine, this is the place to do it. You click Edit, and you go in here, you uncheck DHCP, you type in the IP address, the net mask, and you've configured a static IP address on your machine. You'll probably need a gateway down here, primary DNS server, secondary DNS server, if you're also configuring a static up here. Otherwise, we're just going to use DHCP, and that's going to work fine on our network so far. So I'm just going to say next. Okay, it asked for my time zone. So to configure a time zone, I'm going to use this drop-down box here, and the Big Sky Fishing Supply Company is in Montana. So I'm going to scroll through here, and we're going to find the Mountain Time Zone, which is where Montana is. Now, if we find Denver, scroll up here and look for Denver. There's Denver. So that's where Montana is. It's in the same time zone as Denver. So I'm going to take that city there, Denver, which is Mountain Time. All right. We can say next at this point. Now it's asking us to enter a password. I'm going to make the password Big Sky Fishing. And those are all capital letters at the start. Big Sky Fishing. And click Next. All right, now this is something that's changed between Fedora Core 4 and Fedora Core 5. It has this sort of category here you can choose for groups of software. So there's a ton of software that comes with Fedora, and you can choose to install it when you install the operating system or install it later. And what I know about the Red Hat Certified Technician and Certified Engineer exams are that one of the important things to know is to read in their instructions that they give you at the test what software needs to be installed, and to install it either at the start, install as little software at the start as possible, but just install the software that they ask you to install. So they're trying to get you to use this feature here where you choose what software you want to install when you install the operating system. So one of the things Fedora Core 5 has done is they've grouped these software applications into categories. So it's saying here, what additional task would you like your system to include support for? So basically, what groups of applications do you want to install? By default, it checks Office and Productivity. There's also software development and web server. What I can do is I can choose down here to customize the list of applications now or customize it later. Basically, this means only install whatever applications are listed in this category by default now, and then later I can come back and install whatever else I want to. So we're just going to take the default for now of customize later and install only Office and Productivity software. So I'll say next. Now it goes through and it checks the dependencies. Dependencies are software applications that are required by the applications you choose. So say you choose to install an FTP server. Well, for that FTP server to run, there might be a TCP/IP library that's required. So that TCP/IP library is an example of a dependency. So dependencies are libraries or other software applications that are required by some application that you choose to install. And this is a big deal in Linux. I mean, very rarely in Windows do you install an application that you have to go out and find other applications to make it work. You know, Windows users just aren't used to that. You know, if you install an FTP client from the internet, you just expect it to work. When you install it, You run setup.exe and you expect it to run right after that, right? Well, in Linux, that isn't always the case, unfortunately. You'll go to install it and it'll say, hey, I need the C compiler, I need this TCP/IP library, I need this other SSH library. And you'll have to go get those from the internet to make it work. So that's kind of a negative of how Linux works, but it's getting a lot better. They're getting applications or packaging applications together that make this process easier of installing and upgrading new applications. So we're at the point where it says click Next to begin the installation of Fedora Core. A complete log of the installation can be found at the file /root/install.log after you reboot the system. A Kickstart file containing the installation options selected can be found in root anaconda-ks.cfg. So this file could be used to automate the installation later if you wanted to do the same installation on another server. So for now, I'm going to click Next. And at this point, the installation is going to start. Notice the file system is being formatted. It's transferring the install image to the hard drive. And it says this may take several minutes. Well, believe me, it will. It will take, could take 30 to 45 minutes. In some cases, maybe longer on a slower system, or if you chose to install a lot of applications. So, because of the time frame that this is going to take, I'm not going to sit here and record, 30 to 45 minutes of just the little scroll bar, slowly progressing. I want to point out that during this installation process, at certain points, it will prompt me to insert one of those other 4 CDs. So right now we have disk 1 inserted in the CD-ROM drive. At some point it'll say insert disk 2, disk 3, disk 4 until the installation is complete. Now, depending on the number of applications and the types of applications we chose, it might skip around. It might say insert disk 3, then disk 2, then disk 4. Or it might never ask for disk 3. It might just ask for disk 4, then 2, then be done. So it's a little weird. It's not very predictable sometimes because the CDs that are requested vary based on the applications you chose to install. So you can see right now it's got a little start here, and it's installing this application, 61 megabytes, and it's going to take a while. So what I'm going to do now is I'm going to pause the video, and I'm going to come back as soon as the installation is complete. Congratulations, the installation of our Linux system is complete. Now we have some post-installation questions to answer, and then the system will be ready for use. So at this point, I'm going to click Reboot, and the system will reboot, come back up into a graphical interface, and then we'll have to answer some post-installation questions, and then we'll be done. Now, during the reboot, you won't hear me talking, but just watch the reboot process. Look at all the different services that Linux starts, and Linux will show you the status of every one of those services as it boots. If you click on the little details button, you'll see me click on that during the reboot process. So you can see what works, what didn't work, and you can see the whole process and all the different services and everything that start up. This is vastly different from, say, like a Windows XP startup, where all you get to see is a little bar unless something, seriously crashes and the whole thing fails. With Linux, you get to see every little service, and if one of those services, even if it's a minor service or a less important service, fails, you'll actually get to see it. So I'm going to click Reboot now, and you won't hear me talk until the graphical interface comes back up again. Here we have the post-installation task that I talked to you about us needing to perform before we can begin using Linux. So it says welcome here. There's a few more steps before the system is ready to be used. So I'm going to click forward. First off, we have to answer the license agreement. We have to agree to that. We're not going to go through and read it right now, but if you're having trouble sleeping one night, feel free to go in and read the license agreement. I'm going to click forward. Next up is the firewall. By default, Linux comes with a firewall, and by default it's enabled. If you just click forward here, you enable the firewall and you allow only SSH, which is secure shell. It's an encrypted, you could compare it to an encrypted form of telnet or remote command line access to this Linux server. That's the only thing that's going to be allowed through the firewall by default. If you are going to make this system a web server, you could check HTTP or www here and allow that through the firewall. You could also go down and add other ports, other custom ports to be allowed through the firewall if you wanted to do that. Or, of course, you could disable the firewall, but that's not recommended. So I'm just going to take the default here of enabled and allowing SSH and click forward. The next question here has to do with SE Linux or Security Enhanced Linux. SE Linux provides finer grained security controls than those available in a traditional Linux system. And what I compare this to is like the Windows 2003 rights and privileges system. And if you go over here, you can see there are 3 different choices for SE Linux. The default is enforced. Now, I've read that enforced can actually cause a lot of problems with certain applications, because what it immediately does is it starts denying things, whereas permissive here will only warn you when things would be denied, but it actually allows them to happen. So it's a good way to learn what SE Linux would do for you in certain situations without shutting down things that would normally happen. So I'm going to take that choice. The other choice here is disabled. If you select disabled, SE Linux has to go through here, and it says it takes some time to disable SE Linux in the operating system. So we're going to take permissive, and if you click on the modify SE Linux policy here, you can see some examples of different policies. So for instance, under the HTTPD service, there's a number of different things here that SE Linux would either allow or deny based on the policy or the rights. So here's one that says allow HTTPD to read home directories. So by default that's allowed, but if you uncheck that, HTTPD can't read home directories anymore. So it controls a lot of different services, a lot of different applications and functionality, sort of across the board in all different Linux areas. So I'm not going to change any of these right now, but you can just see how it affects a lot of different services. So we'll click forward. Here's where you set the date and the time. Now the date and the time is set correctly already, but what I want to point out is this Network Time Protocol tab. I'm going to click on that. Network Time Protocol is a network-based time synchronization service. So it synchronizes the date and the time on your Linux server based on some network time server. This is a really handy thing to have enabled. If you check enable here, by default it goes out to the internet and it polls these NTP servers to synchronize the date and time. If you have internal NTP servers, you can remove these servers and add your own servers. So we're not going to enable NTP right now, but I just want to point out that it's something that's available here that synchronizes your date and time. I'll click forward. Next up is the resolution. Here's where you set the resolution and the color depth when the system first starts up. I don't have a lot of resolution, or this is the highest resolution I have on this VMware monitor here. So I'm just going to take the default and we're going to move on. Of course, you can always change this once you get Linux up and running. You can go in and change your resolution and color depth, anytime you want. So I'll click forward. Here's where you create a regular non-administrative user. So this would be a user that you're going to create that isn't an administrator, isn't root, it's just a regular user. Good Linux security practice is to log in as a regular user, and then for any administrative task, you SU to root, or you change user to root, You perform that administrative task and then you go back to your regular user status. Let's go ahead and create a regular user. I'm just going to name this user Jim, and we'll say that the user's full name is Jim Smith, and let's make the password phishing with a capital F. Linux also supports network logon or network authentication. Here I can configure Kerberos or NIS. These are network-based authentication services. So a centralized network authentication database or authentication service. This could be compared to like Windows Active Directory. Windows Active Directory, computer is a member of the domain. You log in with credentials usually that are part of the domain, and that authentication process happens with the Active Directory domain controller, and you're either allowed or denied to log into that computer. Well, Linux can do the same thing with Kerberos or NIS. In fact, there are ways to make Linux work with Active Directory. We're not going to allow those right now, but you just need to know that those are available for you at some point if you choose to do that. Right now we're just going to use local authentication on this local computer. So I'm going to click Next. And here you can test your sound card or configure the device type of your sound card. We're not going to play with sound right now. I'm just going to click Finish. And we completed the post-installation tasks. You'll see some flashes, and then we're at the Linux login screen. So I'm going to come back later to the different options here, but for now let's just log in and make sure we can really log into our new Linux server. So I'm going to log in as root, and the password we said is Big Sky Phishing. And here we go. We have successfully logged into our new Fedora Core 5 Linux box. This is our desktop for the root user. You can see we have menus, we have applications, all sorts of good stuff. We're going to come back to exploring these things in different videos or other videos. For now, I'm just going to minimize this desktop because we have successfully completed our task, which was to install Fedora Linux. So let me minimize this, and I'm going to go back to our slides. So in conclusion, in this video, we talked about identifying the proper hardware for Linux. We talked about reading the release notes to make sure that you have enough RAM, make sure you have enough hard drive space, make sure you meet the minimum or recommended CPU requirements. We talked about how Linux doesn't always have device drivers available for certain things. Of a special concern are laptops. Laptops have so many customized devices that Linux sometimes can have problems running on laptops. Of certain concern are video cards, especially higher end or newer video cards like the 3D video cards that are used for gaming and things like that. A lot of times those don't work with Linux either. So you just need to make sure that the hard drive controller you have, the video controller, and all the other hardware that you have is going to be compatible with Linux. Don't just assume that it's going to work with Linux. Make sure you do a little bit of research to make sure that there are drivers available for the hardware that you're trying to use for Linux. Then we talked about methods for installing Linux. You can install Linux by downloading CDs. You can download a DVD. You can actually install it over a network. There's a variety of different ways to install Linux. And then once you have a way to install Linux, you can do an interactive installation like we did, or you can also script an installation. So a couple of different methods there. We briefly discussed Linux multimedia options. Of course, there's sound cards for Linux. You have to make sure your sound card's compatible. We talked about the purpose for the machine. When you go to install Linux, the Linux operating system is the same operating system really whether you're going to use it as a workstation or a server. But what you need to do is determine what's going to be the purpose of this machine. Is it going to be a web server, an email server? Are you going to do programming or development on this system? Is the system that I have scalable? Is it going to be able to meet the needs in the future for whatever application I'm going to use on this system? We talked about configuring Linux file systems, the ext2 file system, the ext3 file system, how ext3 offers journaling. We talked about the Riser file system. It offers journaling as well. But the ext3 file system is the default for Fedora Linux, and it's also the most popular Linux file system. We talked about boot managers like Grub, Lilo, and eLilo, and how Grub is the default boot manager. And when we booted up Linux there, perhaps at one point you saw a blue screen at the very start that said Fedora Linux, and it said press any key to enter the boot manager. Well, that boot manager was Grub. And since we're just running a single copy of Linux, we don't have any alternate kernels, we're not running another operating system there, we didn't need to use Grub at all. But by default, Grub was installed. We had that choice when we installed the Linux system, whether or not we wanted to install Grub, and we chose to. So Grub's there, and Grub is the default Linux boot manager. We talked about network options. When you configure Linux to be installed, it asks you if you want a static IP address or a dynamic IP address. By default, it does DHCP and tries to pull a dynamic IP address from your network. That was the option we took, but of course you can also configure a static IP address. We talked about other Linux installation parameters, like the keyboard language, the language for the display, different application suites you can install. You can choose to install applications when the system is being installed, or you can choose to install them later. There's a variety of different Linux installation parameters that we looked at, including SE Linux or Security Enhanced Linux, and a few other new Linux installation parameters. Then we installed Linux. You got to see exactly how that works, how the whole process went, and then we rebooted and we completed our post-installation task, and we were able to successfully log into our new Linux server. So with that, we've learned a lot about the installation of Linux, and we've come to the end of video number 3. Thank you very much.